Hey everyone. All right, so I just finished up with period 5, and so I'm going to go through the quiz. I'm going to make this a YouTube video link so you can just fast forward to the question that you want to go over, okay? All right, so first one here, you got a spherical balloon. It's inflated at the rate of 50 cubic meters. Cubic meters per minute, that's a volume, right? Because it's cubic per time, that's a dt. So it's inflated, that's the rate of change of the volume with respect to time. It's positive 50 because it's getting inflated. The rate at which the radius of the balloon is increasing, find that. So find dr dt when the diameter is equal to 20. Okay, so I gave you this formula down here. If you take the derivative of that with respect to time, you bring the 3 down, you get 4 pi r squared dr dt. Okay, I told you that this was 50. Oops, 4 pi. If the diameter is 20, the radius is 10, so we'll square that, dr dt. So this is 100, 400 pi. So if you take 50 and divide by 400 pi, you should get your answer. And then a 0 would cancel. That becomes 1 over 8 and a pi downstairs for an answer of 1 over 8 pi. Okay? All right. Number 2, the radius of a sphere is increasing at a rate of 2. So dr dt is equal to 2. At the instant when r is 12, find the rate of change of the surface area. So find ds dt. Okay, so I give you the formula. If s is equal to 4 pi r squared, ds dt is equal to 8 pi r dr dt. We're looking for ds dt. That's 8, that's pi. The radius they told us was 12. Dr dt was 2. 12 times 8 times 2. 12 times 8 times 2. 192 pi. Okay, for an answer of D. All right, we're cruising. Question number 3. The critical numbers of this function g, sine x plus cosine x, on this open interval. Okay, so critical numbers, if you have g of x is equal to sine x plus cosine of x, g prime is going to be the derivative of sine, which is cosine, derivative of cosine, which is negative sine. Neither of these will be undefined. And so really what we're looking for is where are they equal to 0? Well, that happens when cosine of x equals, if you move that over, you get sine of x. So what you're looking for, you guys, is an angle at which the sine and the cosine are exactly the same. Well, think about your unit circle. Right here at the angle pi over 4, you have root 2 over 2, root 2 over 2. That's the cosine, that's the sine. And so they are the same at pi over 4. They would not be the same here at 1/4, 2/4, 3 pi over 4 because one's negative, one's positive. But right here at 5 pi over 4, you have negative root 2 over 2, negative root 2 over 2, left and down. Okay, so there are two places, pi over 4 and 5 pi over 4, where this happens. And so those would be your critical numbers. Okay, number 4, on a closed interval 0 to 2 pi, the absolute max is absolute maximums. First thing you do is you find your derivative, and the derivative of e to the sine x is e to the sine x. E to the stuff, d stuff, derivative of sine, which is cosine. Again, continuous function everywhere, no issues, right? So it's not going to be undefined. Same thing with cosine. So critical number wise, you just want to know where it's equal to 0. Well, we have that rule. Either e to the sine x is equal to 0 or cosine of x is equal to 0. That never happens. Okay? E to anything is an exponential function that lives above the x-axis. It doesn't happen. But when is cosine equal to 0? Cosine is equal to 0. Remember, every point is cosine comma sine. So if you think about right here at pi over 2, that's the point 0, 1. And so your cosine is 0. That also happens down here at 3 pi over 2. So we have 2 points, pi over 2, 2 angles, pi over 2, 3 pi over 2, inside that interval where You could have a relative max, min, or neither. But if you're looking for absolute, our strategy was find your function value at the left endpoint and at the right endpoint, and then any points in between, which we found to be pi over 2 and 3 pi over 2. Those are our critical numbers. And so let's find out which one is the absolute max value. So I'm plugging into the original function. If I plug in 0, I get e to the sine of 0. Sine of 0 is 0, which just equals 1. If I plug in pi over 2, I get e to the sine of pi over 2. Sine of pi over 2 is 1, and e to the 1 is just e. E to the sine of 3 pi over 2 is e to the negative 1, which is 1 over e. And e to the sine of 2 pi is the same as sine of 0, same angle. And so again, we get e to the 0, which is 1. And what is the biggest of all of those numbers? Well, e is 2.7 and change, right? That's definitely bigger than 1 and bigger than 1 divided by 2.7 and change. And so on the closed interval occurs at the point pi over 2 because that gives you that value of e. All right. On the closed interval 0 to 5, this function has what? If you have a closed interval, there is a theorem that says you will have both an absolute max and an absolute min. There's nothing to do here. You would pick A because there's a theorem, the extreme value theorem, that says if you have a closed interval, no matter how you draw it, does not matter, you will obtain an absolute max and an absolute min somewhere. Even if it's flat, your absolute min and max is every point. Okay? And that was question number 5. Number 6, you've got this function here. How many critical numbers does f have on the open interval? Okay, so definition based. Critical numbers is where f prime is equal to 0 or f prime undefined. Well, they give you f prime and you have a calculator, right? This is clearly a calculator problem. You don't have to do any math here. If you plug in x and then sine of x squared, okay, minus 1 over x, and you're looking on the interval 0 to 2 pi, so let's go from 0 to 2 pi, and you graph that guy. How many times is it 0 or undefined in between 0 and 2 pi? 1, 2, 3, 4. Okay? And so that answer right there should be 4. Now, if you're nervous, right, as you trace, what happens over here, way over here at the end? Well, take your calculator, trace it, come over here, and you can see that it goes from a positive y value right there to a negative y value, and look at your x value. That's less than 2 pi. Right? 2 pi is 3.14 doubled, so it's 6.28 and some change. And then as you continue, right, you're past 6.28, and so this next 0 does not count, right? Because look where you're at. You're already past 2 pi now. Okay, so calculator problem for question 6. All right, question number 7, the graph of f prime. That's super important. F prime is shown below on the closed interval -3 to 5. Where is f decreasing? Definition f decreasing, f prime negative. Where is f prime negative? Wherever this is a graph of f prime, therefore wherever it's below the x-axis. So definitely from -3 to -1. And again from 4, right, all the way to 5. So -3, -1, 4 to 5. Just to point out here, they do brackets here. That might have confused you, but I mean, they were all brackets, so you should have still picked it. But on the AP exam, they will leave those as open intervals. Okay. All right. Question number 8. Given this function, find the values that satisfy the conclusion of the mean value theorem. There's clearly an answer. You do know that this function looks like this. It is continuous and differentiable, so you're good to go. Mean value theorem says find the slope through the endpoints. F of 4 minus f of 0 over 4 minus 0. Okay. F of 4 is root 4 minus root 0 over 4, which is 2 over 4, or 1/2. Nothing tricky yet. F prime is the derivative of that. X to the 1/2, the derivative is 1/2 x to the negative 1/2, which is 1 over 2 root x. And with the mean value theorem, you're supposed to set those equal. So when does 1 over 2 root x equal 1 over 2? Well, clearly, x needs to be equal to 1, right? If x is 1, you get 1/2 is 1/2. If you don't like that, cross multiply and solve. You will get x equals 1. And so your answer there would have been C. Okay. All right, question number 9. For which values of x is the function f decreasing definition f prime negative? So you find your derivative. Your derivative here would be 4x cubed minus 12x squared plus 12x set equal to 0. Factor out a 4 and an x, and you're left with x squared minus 3x plus 3, which would also factor into, what is that? I did something wrong there. 3 times 4 is 12. 2 times 4 is 8. Sorry. So that would be a 2. So this becomes negative 2 and negative 1, which happens at critical numbers of 0, 2, and 1. Those are all places, you guys, where when I plug it in, it makes f prime equal to 0. So if you want to know where it's negative, you need to do an f prime line, and you need to plug in, right, 0, 1, and 2, and look around it. So if I plug in a negative number, okay, let's go right here. Plug in negative 1. That's negative. That's negative. That's negative. 3 negatives makes f prime negative there. If I plug in 0.5, okay, 0.5, this would be positive. This would be negative. This would be negative. 2 negatives makes f prime positive. Plug in 1.5, positive, negative, positive. Therefore, it's negative. 3, positive, positive, positive. So where is it below the x-axis? It seems like if I did that right, less than 0, and in between 1 and 2. Okay, A. All right, question number 10. If f double prime is equal to this, find the x-coordinates of points of inflection. Definition base. What's a POI? F double prime changes sign, right? Memorize it, definition based, point of inflection, f double prime changes sign. Clearly, f double prime equals 0 when x is 0 or negative 1 or positive 2. And so if you did an f double prime line with negative 1 and 0 and 2, and you look at your intervals, you're looking for where this happens. Okay? So let's go plug in negative 5 into f double prime. Negative 5 right there is make that negative. Negative 5 plus 1 squared is obviously going to be positive. This is always positive. It's squared. So I have a negative times a negative, which makes f double prime actually positive. If I plug in negative 0.5, that's negative. This is positive again, always. And then this is negative. So negative times negative is positive. If I plug in 1, positive, positive, negative. And if I plug in 5, I get positive, positive, positive. Okay, so where does f double prime change sign? Well, from here to here, it did not. It's positive to positive. But here I went positive to negative, and here I went negative to positive. So it should be 0 and 2. Okay. All right, question number 11. This is a graph. Okay, a function f is continuous. The graph of its derivative. This is a graph of f prime, circle, right? Make sure you know what you're looking at. At which numbers does f have a local min? Definition local min, f prime negative to f prime positive. Okay, so you want to know where is the derivative at negative value and then positive. Well, right here, f prime is all positive. It's positive. It's above the x-axis. Right here, it's 0, but then right here, it's positive again. So f prime is positive this whole time. And then right here, it's going from a positive value. Now f prime is negative. So at 4, I went from f prime positive to negative. That's not what I'm looking for. That's actually a relative max or a local max. Right here at 5, you guys are going from an f prime negative value to a positive, right? And so at x equals 5, you have a relative or local minimum. Okay, again, just definition based and then graphical knowledge. All right, question 12. This is a quintessential AP exam question. You'll get so much better at these, you guys. So watch how I do this problem. I see a graph. It says F is graphed below, so I need to make sure I know that that's the graph of F. That's important, right? Because now I know that slopes of tangent lines would be F prime. If that was F prime, slopes of tangent lines would be F double prime. So that's a graph of F. I have no idea what they're asking me. So when I look down here, you guys can see that everything is focused on this point 2. And there's the function value, there's a derivative, there's a second derivative. So really, you're supposed to be able to figure out what the heck is F of 2, F prime of 2, and what's F double prime of 2. Okay? And I don't even know what they're asking me because I don't know if I need numbers, but let's just go figure it out. So look at F of 2. This is a graph of F. F of 2 is clearly 0. It's right there. F prime of 2. I don't know the numerical value of it, right? But remember our practice, F prime is the slope of that tangent line, right? If this is F, F prime is the slope of a tangent line. Clearly it's negative here. That's all I know. And what's happening at 2 as far as the second derivative? Well, second derivative tells you guys concavity. This thing is concave up. And if it's concave up, that's the definition of positive. F double prime would be positive. And so if you're trying to put these guys in order, this is the smallest, it's negative, and then it's 0, and then it's positive. So prime, nothing, double prime, nothing, double prime, B is true. Okay, that's like an AP style question that maybe you didn't get, but if that made sense to you, now you play around with that, you'll get better at it. Okay. All right, 3 more. So we've got a derivative, and they give us the derivative factored out, which is nice. At what numbers does F have a relative min? Definition, F prime negative to F prime positive. Underline definition. You know your zeros happen at 0, 1, -2, and -3. And so if you do an F prime line and you start at -3 and then -2 and then 0 and then 1, and you analyze all of these intervals, you're looking for where the first derivative switches from negative to positive. It's in factored form, right? So we can do that same trick. Let's plug in -5. This x squared, you guys, will always be positive, and a positive number doesn't change the sign of anything, right? So we can just ignore that. Plugging in -5, you're going to get negative times negative times negative. 3 negatives makes F prime negative. What about at -2.5? Again, that's always positive. Then this is going to be negative. -2.5 plus 2 is negative, but then this guy would be positive. So I have positive, negative, negative, positive. 2 negatives makes a positive. Same game, plug in -1. Positive, negative, right? Positive, positive. So 1 negative is going to make the overall negative. Plugging in 0.5, positive, negative, positive, positive. So again, negative. What about 10, a number past 1? Positive, 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 positive. F prime will be positive. Okay. All right. And so where does it change from negative to positive? Negative to positive, right there. Positive to negative, no. Negative to negative, no. Negative to positive, yes. So -3 and 1. If you guys don't like that, you could type that in your calculator, right? Graph it and you'll look and you'll see. If you come in here and you type in your function that they give you, x squared times x minus 1 times x plus 2 times x plus 3, and you zoom 6 that, this is a graph of F prime. And the definition of a relative min is when F prime goes from negative to positive, right there at -3. That's positive to negative. That bounces, and then negative to positive right there at 1. So lots of ways to do that. And if you didn't get it on the quiz, I don't care, right? What I care about is, does it make sense to you now? And if I asked you a similar question, could you then get it right? Right? Because the test will count a lot more than this quiz. So you're just kind of using this to gauge where you need to study. All right, determine where the function is concave up. Definition, concave up, F double prime positive. Okay, so let's find the first derivative. This function I'm going to rewrite as 2 times x plus 3 to the -1. I don't want to do the quotient rule there because that's not a function of x, so I don't need to. I can rewrite it. Then my first derivative would be, bringing this down, I get -2 times x plus 3 to 1 smaller times the derivative of the inside. I don't care about first derivative. I care about the second derivative. So if I keep going and bring down negative 2, now I get positive 4 times x plus 3 to 1 smaller. Derivative of inside still 1. And when I simplify that, I get 4 over x plus 3 cubed. Okay? And so where is it concave up? Well, I need to know where it's positive. Well, you can't figure that out unless you first find your critical numbers, right? So where is this thing, f double prime, where is it undefined? Remember, a fraction is undefined when the bottom is 0, which happens at negative 3. Where is f double prime equal to 0? Remember, a fraction is 0 when the top is 0. There's no variable there. 4 is never going to be equal to 0, and so you don't have any critical numbers that come from that. So you only have one critical value on this number line of negative 3. And when you plug in negative 5, let's check the sign of the second derivative. Negative 5 plus 3 is negative 2 cubed is negative, and 4 divided by a negative number is negative. If I plug in 0, 4 over 3 cubed is just a positive number. And so where is it concave up? It seems like from negative 3 forever, which would be A. All right, last one. You've got this function here. It says, which of the following statements regarding the function is not true? Well, it looks like it's asking me about a local min. The only way I'm going to know that is if I find the first derivative. My first derivative is bring down the 4/5 times x minus 1 to 1 smaller, which is negative 1/5. And if I rewrite that, I get 4 over 5 times x minus 1 to the 1/5. Okay? Critical numbers. When is this thing undefined? It's undefined when x is 1. When is it equal to 0? Never, right? We just did a problem like that. The fraction is never 0 because the numerator can't be 0. And so if you analyze f prime, you know that that's the only critical number. So let's figure out what's happening past it. We'll plug in 10. Clearly, 10 minus 1 is 9. Take the fifth root of 9, you get some decimal. It's positive. But what happens at 0? Right, to the left of 1. Negative 1, you can take an odd root of a negative number. That's okay. And so that's going to be negative, and 4 divided by a negative number will be negative. And so I'm going from f prime negative to f prime positive at 1, which is the definition of a local min. So that is true. And then I keep reading. Concave down, inflection point. Both of those deal with the second derivative. So let's find the second derivative. Taking the derivative of this guy, if I bring down negative 1/5, I get negative 4/25 times x minus 1 to 1 smaller, negative 6/5. Derivative of inside is just 1, so nothing changes. If I rewrite that, I have negative 4 as my numerator, 25, x minus 1 to the 6/5. Okay, and then the game is the same. When is this thing undefined? Well, a fraction is undefined when the denominator is 0, which happens at 1. When is f double prime equal to 0? You guys sick of me saying this yet? Because that's good. A fraction will be 0 when the numerator is 0, which doesn't happen. So none. So I have one critical number of f double prime, and its value is 1. So let's figure out what happens around that. Let's plug in 10 again. If I plug in 10, I got 9 raised to the 6/5 power. You guys have a calculator. You can just plug in 10 and it'll tell you that that's going to be negative. But it's negative because this is positive. Then you have a negative divided by a positive, so you have f double prime negative. If I plug in 0, I've got negative 1 to the 6/5. Now be careful here. Okay? Negative 1 to the 6/5. The bottom number is the root. When you take the fifth root of negative 1, you get a negative number. But then what are you going to do? You're going to raise it to an even power, which will always make that positive. And so this ends up being negative divided by positive, which is negative. Okay? And so right there, what happened? It says f is concave down from negative infinity to 1 and 1 to infinity. Yep. The point 1, negative 2 is an inflection point. An inflection point is f double prime changes sign. Did I change sign here? No. So this was true. This was false. Okay. It says f has a vertical tangent at 1, -2. What's that? Well, what's a vertical tangent? A vertical tangent would have an f prime value. Vertical tangent is f prime undefined, right? Because isn't the slope of a vertical line undefined? So go to that point, 1, -2. Go plug in 1 to your first derivative. Didn't we say that that makes it undefined? So this is true. Okay? All right, you guys are doing great. Those are hard questions, right? But they are definition based. They are questions where if you study them, you will get better at it. Okay? And so we're gonna just kind of push on, man. We're cruising. We're gonna finish this chapter and get into integrals, which is a whole nother part of the class. And then we'll come back to this when we start taking practice exams. You guys will get better and better at it. See ya.